Okay, dear students, now we are going to solve the problems of chapter number 12, which is on page 261. So the first question, wavelength, which is denoted by lambda, is equal to 0.1 nanometer. Nano is 10 power minus 9. Therefore, instead of nano, you will write in its value, that is 10 power minus 9 meter. Frequency f, you have to find out. Velocity of sound wave is 3 into 10 raised to 8 meter per second. Now we have to find out the frequency, then we will select this formula V is equal to f lambda. But you have to find out the f, then lambda will be upon V. So formula will be converted as V, f is equal to V upon lambda. So V is 3 into 10 raised to 8 and lambda is 0.1 into 10 raised to minus 9. So it will come 10 power 8, this one, and this minus sign, it will come on as a numerator, then its power will be positive. 8 plus 9 and 0.1, it is also positive. So it will become f is equal to 3 into 10 raised to 18 hertz. This is the frequency answer. Next, numerical number 2, its data is mean vibrations. Vibrations are 256 and time for these 256 vibration is 1 second. When we will divide the vibration by time, it will become frequency. So f is equal to vibration upon time, mean 256 upon 1 is equal to 250 hertz. This is the frequency. And the wavelength lambda is equal to 1.3 meter. You have to find out the velocity of the wave as well as time period. Now for the time period, you know that time period is equal to 1 upon f. So 1 upon 256, by solving it, it will come 3.9 into 10 raised to minus 3 second. Now for the velocity, V is equal to f lambda. F is 256, lambda is 1.3. By multiplying both the values, you get 332.8 meter per second. This is the velocity of the wave. Next, numerical number 3, data. There are two sound waves producing by the radio station. One is AM radio wave and other is FM radio wave. AM radio wave, its frequency is 1230 into 10 raised to 3 hertz and its velocity is 3 into 10 raised to 10 centimeter per second, and wavelength you have to find out. Likewise, FM radio waves, its frequency is 91.9 into 10 raised to 6 hertz and its velocity is same, 3 into 10 raised to 10 centimeter per second. You have to find out the lambda, mean wavelength of FM wave. Now first of all, we will find the wavelength of AM radio waves. The formula is V is equal to f lambda. You have to find the wavelength, means f will be upon the velocity, V upon f, because it is over here multiplying. Here it will come and it will be divided. So lambda is equal to V upon f. V is 3 into 10 raised to 10, while the f is 1230 into 10 raised to 3. Now your answer will be, by calculation of this thing, your answer will be lambda is equal to 24390, 24,390 centimeter, the wavelength of AM radio wave. Now we'll come to the wavelength of FM radio wave. Formula is V is equal to f lambda. Now lambda is equal to V upon s, and 3 into 10 raised to 10 divided by 91.9 into 10 raised to 6. It will come 326.44 centimeter, the wavelength of FM radio wave. Next, numerical number 4, time period you have to find out. Time period of simple pendulum you have to find out, and length of the simple pendulum is 144 centimeter divided by 100, it will become meter. So 1.44 meter. Now value of G is 9.8 meter per second square, while the value of pi is 3142. Now solution. Our formula is T is equal to 2 by L over G root. Now by putting the values, T is equal to 2 multiply value of pi 3.142 and value of length L 1.44 upon the value of 9.8 of the G. Now T is equal to, by multiplying this one, it comes 6.284 multiply the value of root. By calculating the value of root, then multiply by 6.284, it comes 2.41 seconds. So the time period of simple pendulum is 2.1441 second. Now question number 5. Mass of the body is 0.3 kilogram, while spring constant by which the body is attached is 5 Newton per meter. Pi is equal to 3.142, and you have to find out the time period. So for this horizontal formula is T is equal to 2 by m upon k root. T is equal to 2 into 3.142 value of pi, 0.3 is the value of m, and k is the constant value of k. So by dividing this and multiplying 2 and 3.142, we got 6.284 multiplied by calculation of root this value, we get the time period T is equal to 1.54 second. Next, numerical number 6, vibration of a paper. There are 50 vibration, time is 5 seconds. Now we will calculate here the frequency. Vibration upon time means 50 upon 5, that is 10 hertz. Our frequency is 10 hertz, and you have to calculate the time period T as well as the velocity of the vibrations of the paper. Now lambda is equal to 10 centimeter. Solution, the first formula, T is equal to 1 upon F, T is equal to 1 upon 10, mean 0.1 second. This is the time period, and F is 10 hertz. This is the frequency. Now V is equal to F lambda. You have to find the value of V, that is 10 frequency, and lambda is equal to 10 multiplied, it comes 100 centimeter per second. So this is the velocity. Now these are our 3 requirements: frequency 10 hertz, which is calculated by this formula; time period 0.1 second, that is calculated by this formula; and velocity of the paper, that is 100 centimeter per second, is calculated by this formula. So these are the answer of this question. Next, number 7, data. There are 40 waves and time is 2 seconds. Now here we will calculate first frequency, waves upon time, mean vibration upon time 2, that is 20 hertz, and velocity is 3.5 meter per second. You have to find out the wavelength lambda. Our solution and formula is V is equal to F lambda, and you have to find out the lambda, then F will be divided. So F lambda is equal to V upon F, and lambda is equal to 3.2 upon 20, that becomes 0.175 meter, the wavelength. Now question number 8. There is a second pendulum. Second pendulum is that pendulum in which its time of one vibration is 2 seconds. Any simple pendulum having time of vibration, that is 2 seconds, one vibration. For one vibration 2 seconds. That type of simple pendulum is called second pendulum. So its time period is 2 seconds. G is 9.8 meter per second square, and pi is equal to 3.142. Now come to the solution. So the formula is T is equal to 2 by L over G root. Instead of T, you will write 2 and 2 by 2. This is the value of pi, and L upon G 9.8. So 2 is equal to, by multiplying this 6.284 L over G 3.13, the root of 9.8. Look at it. This is the root of 9.8 we have calculated. Instead of 9.8, we will write 3.13, and there is no root on the 9.8. So it will be multiplied here by 2. Because here it is dividing, here it will be multiplied by 2. So it comes 6.26, and 6.284 is multiplying by root L. So it will be divided here. So 6.26 and 6.284 is equal to root L. By squaring both sides, we will get the square of this value, and this value, root will be removed by the square, so it becomes L. L is equal to 0.99 meter answer. So it is the end of the chapter. These are the numericals. Please write these numerical and learn these numerical, its formula. We will start next chapter, that is 16th chapter, in other class.